what we're going to do now is we're going to do, if there's a mixture of a strong acid and strong base. So up until now we've been still dealing with strong acids and strong bases. It's really important. So I'm just going to go, I'm going to choose the numbers they've done for an example on page 8. Because we want to get when there's an excess of H pluses and excess of OH minuses. So if you have an equal amount of H plus and OH minuses, obviously it's going to be neutral. So remember, neutral is H plus is equal to OH minuses. So that's why water is neutral. But we're not interested in that right now. So what we're interested in is the mixture of strong acids and strong bases. So in their first question, they have 50 centimeters cubed of 0.1 mole Dm minus 3 of H2SO4. So what we're going to do first is we're going to work out the amount of protons. So our concentration of H2SO4 is going to be equal to 50 over 1000 times by 0.1. And that gives us a number it's not given us. Brilliant. Our H pluses, because this is diprotic, it's going to be twice this. So that's going to be equal to 2 times 50 over 1000 times by 0.1. And they give us that answer, and that is 0.01. So we've got a constant. Sorry, this is not concentration. This is just moles, isn't it? I'm being a bit special. Right. So we've got moles. We haven't got concentration. Apologies. We've just got amount of moles. So we've worked out the amount of moles of H plus. So our moles of H plus is equal to 0.01. We now want to work out the moles of OH minus. So how much have we got? We've got 25 centimeters cubed of 0.15 mole Dm minus 3. So we've got one hydroxide, so it's just going to be NaOH is equal to 25 over 1000 times by 0.15, and that gives us 0.00375. So we've now got the moles of OH minus, and that is equal to 0.00375. So what you need to do now is you need to realise which number is bigger, this one or this one. This number is bigger, so you have an excess of H pluses. So we can do 0.01 minus 0.00375. That is going to give us the amount of protons left over. So we have 0.00625. So we now have our moles of H plus, which is equal to 0.00625. We want the concentration of H plus ions, so that's going to be equal to 0.00625. And our total volume is going to be 25 plus 50. So our total volume is 75 over 1000. And that will give us our concentration of 0.0833. We've got a concentration of H plus ions. We can just now do the minus log of 0.0833. And that gives us 1.08. And when we do our minus log, because we know that there's an excess of H pluses, it's going to be acidic, so we're going to have a lower number. So that's when there's an excess of protons. It's very similar when we do excess of hydroxide ions. So we'll get rid of this. So if we look at their next example, again, because their numbers will be easy, we've got 25 centimetres cubed of H2SO4, and concentration is 0.25 mole per dm-3. So to work out the moles of H2SO4, you would just do 25 over 1,000 times by 0.25. So for the moles of H plus, because it's diprotic, we're going to do 2 times 25 over 1,000 times by 0.25, which gives us 0.0125. So we've now got our moles of H pluses. Now we want to make our moles of OH minuses. So we've got 100 centimetres cubed of NaOH, NaOH, and the concentration is 0.2 moles per dm-3. So again, we're just going to do 100 over 1,000 times by 0.2. So that is our moles of OH minus. So we've now got our moles of OH minus and our moles of H plus. We recognise that this one is greater, so this one is in excess. So our remainder of our moles of OH minus is going to be 0.02 minus 0.0125. So that's going to give us 0.0075 moles of OH minus left. Now our concentration of OH minus is going to be 0.0075 over the volume. So the volume is 125 in total. And that gives us our concentration of OH minuses to be 0.06. We've now got concentration of OH minuses. We have to go back to our ionic product. So Kw is equal to H plus times OH minus. So we can rearrange that. So Kw over OH minus is equal to H plus. So we put in our numbers. So Kw is 10 to the minus 14. We're going to divide that by our concentration, 0.06. And we get, where is it? 1.67 times 10 to the minus 13. So we're just going to do minus log of 1.67 times 10 to the minus 13. That gives us 12.78. So sense check, it's high pH, so it's going to be alkaline. We've got an excess of OH minuses, so we're happy. So the steps are really work out your H plus ions, or moles of H plus, work out moles of OH minuses, work out which one's in excess, find what they're in excess by. If it's H plus, you just find the concentration and you do the minus log of it. If it's OH minus, you have to use the ionic product to work out H plus, and then minus log of the H plus. Right, so what you're going to do is you're going to do tasks 4 and 5 on page 9. Again, any questions, please do ask them.